Hello everyone, I'm Prachiti and alongside me is Rishikesh. Today we'll be presenting our project ExpenseLens, which is a smart expense management system. Let's get started. Going ahead, I'll be covering the project goals, software components, system architecture, and Rishikesh would be talking about debugging and testing strategies, our learnings, limitations, and improvements. As we know, expense management is kind of a daily challenge for all of us. It seems time consuming and is error prone as we have to do some kind of manual tracking. Therefore, we are introducing an intelligent system that leverages OCR technology and intelligent categorization, which allows users to effortlessly organize their expenses while gaining valuable insights into their spending patterns. Now, in terms of functionalities, ExpenseLens goes beyond traditional expense management systems. First of all, we capture relevant information from receipts and invoices using OCR technology for efficient image processing. Then, our data categorization module extracts essential entities such as vendor details, location, product information, etc. So, it's totally user centric, which allows customizable expense categories for enhanced personalization. We are also providing users with a dynamic analytics dashboard, enabling real time insights into their spending habits and expenditure trends. And lastly, we have provided the user the ability to verify and customize extracted details, which ensures accuracy. And we are also addressing potential discrepancies when some kind of data is missing while we extract details from the invoices and receipts. Now, let's dive into the core of ExpenseLens, that is its software components. For the front end, we have implemented a user activity portal and a dashboard. This is where you, as a user, interact with ExpenseLens. From uploading receipts to verifying details and exploring the analytics dashboard, it's all designed for a seamless interaction. For the backend functionality, we have implemented two dedicated microservices. One is the OCR module, and the second one is the ExpenseLens core module. We have used Redis as the caching service, and our persistent data storage is the Postgres service by GCP. So we are using this database to store crucial information like user login details, then user receipt mappings, and all the categorized information and the receipt details. We have utilized GCP's storage bucket to store receipts and invoice images, which would be uploaded by the users. And certain components, including Flask application, OCR module, Redis cache, are containerized using Docker. And lastly, we have used Kubernetes as the orchestrator for easy maintenance of our containerized components. Now let's go through the architecture diagram. As a user, you start by interacting with the user activity portal and dashboard UI. Here you can upload receipts, verify details, and access the analytics dashboard. Once the user uploads a receipt or invoice, the user's actions triggers requests that are sent to the API interface. This backend component, manages the overall workflow, that is, receiving your inputs and also coordinating with the entire system. From here, the receipts are pre-processed and stored right away into the storage bucket. This step also triggers the OCR module, which is our first backend service. It processes the receipt images. It extracts relevant details using the OCR technology. And internally for this functionality, we are using a third-party API service. Now the extracted details from the OCR module are then temporarily stored into the Redis cache. With this step, we are storing the raw details and sending them over to the user activity portal for user verification. Once the user verifies the relevant details, they are then permanently stored into the main Postgres database. From here, the ExpenseLens core module takes charge of orchestrating the analytics operations. And this module is again hosted as a different microservice. Once the analytics operations are performed, it is then displayed to the user using the dashboard. Now I will hand over to Rishikesh, who would talk about the testing and debugging strategies.
Yeah, since testing and debugging are crucial for every stable application, in this project we have implemented some effective strategies like unit and integration testing using tools such as unit test frameworks. Our test also covers various components from Flask endpoints to OCR functionalities as well. For real-time insights, we use debugging techniques like strategic debugging statements and interactive debugging, which involves capturing runtime information in a Redis cache via logging microservice. And for Kubernetes, since it already has inbuilt logs in it, so debugging in Kubernetes was relatively easy. For the next slide, we'll talk about learnings. Yeah. So while building this application, we made use of JavaScript's capabilities to add dynamic features and visualization to our application to give a user-centric experience. Our project's functionality and scope were increased by connecting to the Google Cloud Service and smoothly integrating an external service as well. By finding a balance between automation and user customization, we were able to efficiently serve a wide range of user needs and also explored some real-time insights with the emphasis on improving visualization for quick and powerful data interpretation. One of the most important part of our plan was making sure that all the microservices were communicating with each other effectively, which helped our integrated system run smoothly. We have strengthened the functionality and responsiveness of our application with these insights. Uh, for the next slide, talking about limitations and improvements, since depending too much on an external OCR API possesses a risk to our applications, and the basic authentication mechanism is a security limitation, making our system more vulnerable. Handling a lot of users at once is also a challenge to itself, and to improve, I think we should reduce the reliance on our external APIs, enhance security with better authentication, and work on making the application handle more useful users effectively. Coming into the improvements, we can make our expense app more efficient by introducing load balancing strategies, ensuring which ensures a smoother performance by eventually distributing server traffic. The implementation of CI/CD pipeline ensures regular updates, allowing for quick and reliable feature rollouts with automated testing and code analysis. To ensure a user experience, we can add a machine learning model for expense forecasting and can be improved categorization prediction. These smart features anticipates future expenses and provide more accurate categorization, which ultimately saves a user's time. For that, machine learning model should undergo a thorough testing to ensure its reliability and adaptability to a diverse user behavior. So in a nutshell, we can optimize the app performance with these techniques for better expense management in our expense app. So we'll we can head out to the demo. So here is the demo for ExpenseLens application. This is our login page. For the front end, we have utilized plain HTML, CSS, and JavaScript for building the elements. Since the focus here was to understand how to build the distributed software systems and handling of the interaction between individual components, we decided to use basic front-end capabilities for our project. Now let me log in as a user, test user. Test password. Yep, once I hit the login, it will redirect it to me to the main dashboard page. Yeah, so here's the dashboard page. Now let me show you how a user can upload the receipt. I have already a demo receipt on my laptop, so I'll just use that. Yeah, once I click on the upload button, it will redirect it to me to the verification page. Yeah, so here's the verification page. You can see all the categories, merchant names. If you go into the categories, you can see all these categories. We'll select just the grocery and can just see all the data over here. So date here is none. We can just change that date since it could not OCR could not capture it. We'll use it to this date, and after verifying everything, we'll hit on the submit button. So yeah, once it's submitted, it will be redirecting to the main dashboard page once again, and the user receipt is already can see reflected in the transaction page here clearly. Also, you can see in the first section, in the dashboard sections, there's a percentage change card. It reflects the percentage change in the spending for the current month compared to the previous month. Here, the second card shows the amount spent by the current user in this month, and the third card shows the which category the customer has spent most for this month. To show a detailed view of the expenses, we used pie chart for the category-wise spending, and this transaction here shows the latest 5 transaction details. And lastly, we have chart that shows the overall spending for this user. Yep, that's it. And thank